Hello, my name is David Shaw. I'm here today to introduce the Genix Test Unit, which is our automotive sub-assembly electronics test unit. I'm going to show you how to connect the Genix Test Unit to harnesses within spoilers and bumpers to make sure that the correct components have been fitted during manufacture. Later on, I'm going to show you how to adapt the unit for different vehicle programs, and then we can start doing some testing. Let's get started. The Genix Test Unit has been designed to test components typically found in automotive bumpers and spoilers in a factory floor setting. It can perform three types of testing. The first is simple continuity testing. The second, advanced continuity, checks that the component is in place and also that it is the correct type of component. The third type of testing, functional testing, checks that the component is in place and also tests whether it's working as it should be. In a production setting, the Genix Test Unit is installed in the electrical cabinet of the assembly station and is wired both to the PLC of the assembly station and from its measurement I/O to a zero insertion force or ZIF connector. The ZIF reduces wear and tear to parts of the device under test, for example the harness connector, which is only designed to be plugged in a limited number of times. It also allows easy replacement of consumable contact pieces within the test fixture. At the Genix Test Unit's opposite end, the unit is wired directly to the PLC, which initiates the test sequence and monitors its results. So, how does a Genix Test Unit work? Well, for the purpose of this demonstration, we have a Genix Test Unit here, which is connected to the vehicle harness via two ZIF connectors. For the purpose of this demonstration, we'll focus on testing just two sensors. In a real-world test scenario, test results for each item attached to the harness would be sent directly to the PLC as either high or low inputs. Given that we do not have an assembly station to hand, we'll instead use a PC-based GUI to monitor the test results. This is an application built using our real-time interface creation software VisualConneX. It's used during development of the Genix Test Unit to assess whether each measurement I/O reports a pass or a fail. Each Genix Test Unit comes complete with the firmware required for both the vehicle program and the specific bumper or spoiler that is looking to be tested. In this instance, we've pre-configured our Genix Test Unit for use with this specific bumper. When any test begins, a number of signals are sent from the PLC to the Genix Test Unit, firstly to configure which type of sensors are being tested, and then to configure the engineering revision of those sensors. And there are similar signals that are sent from the PLC to the Genix Test Unit when testing other types of equipment. In this instance, we're going to be using a small box which will generate the signals that will normally be sent from the PLC to the Genix Test Unit. Of course, the PLC would know which piece of equipment it was testing because of the barcode scan. We can now run our test. As you can see, the GUI has picked up that the two sensors that are correct have passed, whilst the rest of the sensors have failed. The test process only took a few seconds from start to finish for all harness components. Moving on, we can verify the results of our test by removing one of the sensors and seeing what the results are then. As you would expect, the GUI has now picked up that one of the sensors has failed. And just to complete the cycle, we'll connect both sensors back to the harness and run the test one more time. So within a short space of time, we've managed to put together a demonstration that shows the correct sensors being fitted to the harness within a production setting. Join us next time when we'll talk about the Genix Test Unit in a little more detail.